The year was 1823, and America was transforming from an agricultural nation into an industrial powerhouse. In a small Vermont workshop, Thaddeus Fairbanks was perfecting a revolutionary invention that would launch one of the country's most enduring industrial empires. His platform scale could weigh a fully loaded wagon without requiring the cargo to be unloaded, a breakthrough that would make the Fairbanks name synonymous with precision and reliability across America. What began as a simple scale-making operation in St. Johnsbury, Vermont, would eventually evolve into Fairbanks-Morse. Over time, it became a manufacturing giant that powered American submarines in World War II, supplied naval engines deep into the Cold War, and powered railroads across the continent. The name became so trusted that the Fairbanks Standard became a benchmark for precision. But this is also the story of how even the mightiest industrial empires can crumble when they misjudge their markets. Thaddeus Fairbanks' platform scale solved a problem that plagued commerce for centuries. Before his invention, weighing large quantities of goods required complex systems of levers and counterweights that were both inaccurate and cumbersome. The Fairbanks scale used a simple lever system that could accurately weigh anything from a bag of grain to a railroad car full of coal. By the early 1830s, Fairbanks scales were spreading fast because they solved a problem every town in America had. The success of the scale business provided capital for expansion into other mechanical devices. Then came the expansion that changed everything. In 1865 to 1866, Charles Hosmer Morse helped turn Fairbanks from a scale company into a national industrial powerhouse. As Morse expanded the business in the 1860s onward, Fairbanks-Morse diversified into pumps, engines, windmills, building the toolset of industrial America. The company's expansion into windmills during the 1870s demonstrated its ability to identify and dominate emerging markets. As American farmers pushed westward into regions where water was scarce, Fairbanks-Morse windmills became essential for irrigation and livestock watering. One of the most famous windmills on the frontier, the Eclipse, debuted in 1873 and later became part of the growing Fairbanks-Morse empire through acquisitions. By 1880, Fairbanks-Morse windmills dotted the landscape from Texas to Montana. The company became one of the dominant forces in the American windmill market, generating millions in revenue and establishing dealer networks in every major agricultural region. This success taught Fairbanks-Morse valuable lessons about the importance of reliable field service and local dealer support. Lessons that would prove crucial in later ventures. The transition into stationary engines began in the 1880s as American industry demanded more reliable power sources. Steam engines dominated industrial power, but they required skilled operators and constant attention. Fairbanks-Morse recognized an opportunity to develop simpler, more reliable alternatives for smaller industrial applications. The company introduced its first commercially successful gasoline engines around 1893. They were rugged single-cylinder models built for farms, workshops, and small operations, before scaling up to larger stationary and industrial power plants later in the decade. The engineering philosophy that guided these early engines would define Fairbanks-Morse for decades. Build them heavy, build them simple, and build them to last. By the early 20th century, Fairbanks-Morse had grown into one of the largest and most diversified industrial manufacturers in the United States. The company produced scales that weighed everything from letters to locomotives, windmills that irrigated millions of acres, and engines that powered industries across America. The development of diesel technology in the early 1900s presented Fairbanks-Morse with its greatest opportunity and its ultimate challenge. Rudolf Diesel's compression ignition engine promised greater fuel efficiency and reliability than gasoline engines. But early diesel designs were heavy, noisy, and difficult to start. Most American manufacturers dismissed diesel as impractical for anything but the largest industrial applications. Fairbanks-Morse engineers saw potential where others saw problems. In the early 1910s, the company invested heavily in diesel research, developing engines for marine applications where weight was less critical than reliability and fuel efficiency. These early marine diesels powered fishing boats, tugboats, and small cargo vessels, establishing Fairbanks-Morse as a serious player in the emerging diesel market. In the late 1930s, Fairbanks-Morse unveiled a weird, brilliant machine, the opposed-piston diesel, inspired by earlier European opposed-piston work, then ruggedized into an American workhorse. Two pistons race toward each other in the same cylinder and ignite fuel between them. No cylinder head, fewer failure points, and insane power density for the size. The opposed piston design was mechanically elegant and theoretically superior to conventional diesels. The absence of cylinder heads eliminated a major source of mechanical failure, while the symmetrical piston arrangement reduced vibration and wear. Testing proved the opposed piston concept's advantages. Fairbanks-Morse's prototype engines produced significantly more power per pound than comparable conventional diesels, while consuming noticeably less fuel. The engines ran smoother, lasted longer, and required less maintenance than traditional designs. By the late 1930s, Fairbanks-Morse was producing opposed-piston diesels for marine, industrial, and power generation applications. World War II catapulted Fairbanks-Morse into the front ranks of American defense contractors. The U.S. Navy's desperate need for reliable diesel engines to power submarines and a wide range of diesel-electric naval vessels created unprecedented demand for the company's opposed-piston technology. What had been a promising but relatively small market segment suddenly became a matter of national survival. The Navy's submarine program presented unique engineering challenges that played directly to Fairbanks-Morse's strengths. Submarine engines needed to be compact, powerful, and absolutely reliable. A diesel engine failure hundreds of feet underwater could mean death for the entire crew. Traditional diesel designs were too large and complex for submarine applications, but the opposed piston configuration offered the power density and reliability that submarine warfare demanded. Fairbanks-Morse's Model 38D818 submarine engine became one of the main engines behind America's fleet submarines in World War II. These engines produced 1,600 horsepower from a package that weighed just 32,000 pounds, remarkable power density for 1940s technology. Each submarine carried 4 of these engines, providing the speed and range needed for Pacific operations against Japan. The submarine engine contracts transformed Fairbanks-Morse's financial position. Between 1941 and 1945, the company delivered over 1,000 submarine engines for the U.S. Navy, worth hundreds of millions of dollars in wartime contracts. The Beloit facility operated around the clock, employing 15,000 workers who produced engines as fast as shipyards could install them. Beyond submarines, Fairbanks-Morse engines powered a wide range of diesel-electric naval vessels, proving they could run hard for thousands of hours when failure wasn't an option. These engines proved remarkably durable under combat conditions, often running for thousands of hours without major maintenance. The wartime production surge established Fairbanks-Morse as one of America's premier diesel manufacturers, and that battlefield credibility gave Fairbanks-Morse something priceless: confidence. Military contracts also funded extensive research and development that advanced diesel technology significantly. The end of World War II in 1945 left Fairbanks-Morse in an enviable position. The company had proven manufacturing capabilities, advanced diesel technology, and substantial financial resources accumulated from wartime profits. Company executives surveyed the post-war landscape and saw enormous opportunities in the railroad industry's transition from steam to diesel power. Convinced that their opposed piston technology gave them a real edge, Fairbanks-Morse believed it would dominate the diesel market once customers understood its benefits. In 1944, while World War II still raged, Fairbanks-Morse made a decision that would define the company's post-war future. Observing the railroad industry's gradual shift from steam to diesel power, company executives decided to enter the locomotive market with their proven opposed piston technology. It seemed like a logical extension of their diesel expertise. If Fairbanks-Morse engines could power submarines and major naval vessels, surely they could power locomotives. The locomotive market in 1944 appeared ripe for disruption. General Motors' electromotive division dominated with roughly 70% market share, while American Locomotive Company held most of the remainder. Both companies used conventional diesel designs that Fairbanks-Morse engineers considered inferior to their opposed-piston technology. Development of the first Fairbanks-Morse locomotive began in 1944 at the company's Beloit facility. Engineers adapted their successful Model 38D8 submarine engine for railroad use, creating a 2,000 horsepower locomotive that could outperform anything EMD or ALCO offered. The opposed piston design provided greater power density than conventional diesels of similar size while consuming less fuel. In December 1945, the first Erie-built units rolled out of GE's Erie, Pennsylvania plant, Fairbanks-Morse's shot at the big leagues. The locomotive featured a distinctive carbody design powered by a single 10-cylinder opposed-piston diesel rated at 2,000 horsepower. This was significantly more powerful than EMD's standard F unit, which produced only 1,500 horsepower. Early testing results were impressive. The Erie-built locomotives demonstrated superior fuel economy and pulling power compared to EMD and ALCO units. Initial orders were encouraging. The Erie Railroad ordered 8 units, followed by orders from the Pennsylvania Railroad, Milwaukee Road, and Southern Railway. By 1947, Fairbanks-Morse had delivered over 100 locomotives and appeared positioned to become a major player in the diesel market. However, problems began emerging as Fairbanks-Morse locomotives entered regular service. The opposed piston engines, while powerful and efficient, were more complex to maintain than conventional diesels. Railroad mechanics, accustomed to working on EMD and ALCO locomotives, struggled with the unfamiliar opposed piston design. Simple maintenance tasks that took hours on conventional locomotives required days on Fairbanks-Morse units. The service support infrastructure that EMD and ALCO had built over years of locomotive production proved crucial. Extensive field representatives, parts depots, and training programs that kept their locomotives running reliably. Fairbanks-Morse, entering the market as a newcomer, lacked this support infrastructure and struggled to provide the service levels that railroads demanded. Parts availability became a persistent problem. EMD and ALCO had standardized their locomotive designs and maintained large inventories of replacement parts at strategic locations across the country. Fairbanks-Morse's opposed piston engines used unique components that weren't interchangeable with other manufacturers' products. When a Fairbanks-Morse locomotive broke down in remote locations, railroads often waited days or weeks for specialized parts to arrive. Railroad purchasing decisions also reflected factors beyond pure technical performance. Many railroads had established relationships with EMD or ALCO that included favorable financing terms, trade-in allowances for old equipment, and comprehensive service agreements. Fairbanks-Morse, as a newcomer, couldn't match these established relationships and often found itself competing primarily on price rather than value. EMD's F-Series freight units competed most directly with the Erie-built, while the GP7, introduced in 1949, marked a shift toward versatile road switcher designs that would reshape the diesel market. Fairbanks-Morse's locomotive sales peaked in 1950 at 190 units, but declined steadily thereafter. By 1954, annual production had fallen to fewer than 50 locomotives as railroads increasingly standardized on EMD and ALCO products. The company's market share briefly surged during its early momentum, but dropped to less than 5% by the mid-50s. The final blow came from changing railroad preferences. The industry was consolidating rapidly, with larger railroads absorbing smaller ones and standardizing their locomotive fleets to reduce maintenance costs. This consolidation favored manufacturers with the largest installed bases and most comprehensive service networks, advantages that EMD and ALCO possessed and Fairbanks-Morse lacked. By 1956, the writing was on the wall for Fairbanks-Morse's locomotive ambitions. Orders had dwindled to a trickle, and the company was losing money on every locomotive produced. The Beloit facility, which had been expanded during the optimistic early 1950s to handle projected locomotive demand, operated at less than 25% capacity. By 1958, Fairbanks-Morse was done in the U.S. market. A few years later, the final export units shipped out to Mexico in the early 60s, and the dream was over. After selling roughly 1,460 locomotives, Fairbanks-Morse walked away from the market. The locomotive exit was part of a broader corporate restructuring that reflected changing market realities. The diversified industrial giant that had thrived in the early 20th century was struggling to compete in increasingly specialized post-war markets. Companies like General Motors and Caterpillar were achieving economies of scale by focusing on specific product lines, while Fairbanks-Morse's broad product range prevented it from achieving similar efficiencies. Corporate management decided to focus on markets where Fairbanks-Morse's opposed-piston technology provided genuine advantages that customers valued enough to pay premium prices. Military and marine applications remained strong, as did specialized industrial markets where reliability and performance mattered more than initial cost or service convenience. The U.S. Navy continued ordering Fairbanks-Morse engines for submarines and surface vessels throughout the 60s and 70s. The design remained indispensable for military applications long after it disappeared from American railroads. These contracts provided steady revenue and maintained the company's engineering capabilities even as commercial markets declined. Power generation became another focus area where Fairbanks-Morse's technology found receptive customers. Electric utilities needed backup generators that could start quickly and run reliably during power outages. The opposed-piston engine's rapid start capability and proven durability made them attractive for standby power applications, even though they cost more than conventional alternatives. By 1960, Fairbanks-Morse had transformed from a diversified industrial giant into a specialized manufacturer serving military defense and niche commercial markets. Employment at the Beloit facility had fallen dramatically from its wartime peak, but the remaining business was profitable and sustainable. The technology had been superior, but superior technology alone wasn't enough to overcome established competitors' advantages in service support, dealer networks, and customer relationships. Market consolidation accelerated throughout the 60s as the diesel locomotive industry matured. EMD's dominance became overwhelming by the mid-1960s. Alco struggled with its own competitive challenges and eventually exited the locomotive business in 1969. Fairbanks-Morse itself survived as a much smaller entity focused on defense contracts and specialized industrial markets. Various corporate reorganizations and ownership changes occurred over the following decades, but the Fairbanks-Morse name persisted in niche markets where its engineering reputation retained value.